And I'd say those are probably the cleanest versions of the equations I have, right? Now what? Any requests? Last time I moved everything to one side, right, and factored, set equal to 0. Can't do that this time. Any ideas? Somehow set them equal to each other? Okay. How? Substitute? Yeah. How? You want to solve one of them for lambda and then maybe plug that into the other one? Or you could solve them both for lambda, couldn't you? And set them equal to each other? Yes, right? Everything is, you're free to do algebra at this point. You just have to be careful. So let's solve for lambda, okay? Let me solve for lambda. And let's do equation 1. And I'm going to do my work right here. I'm going to take equation 1, and it implies that 2 over x equals lambda, right? But I just did something. What did I do? Divided by x. So I need a little disclaimer in here. I need to let everyone know that the only way that that's happening is if x isn't 0, right? So before I start this, I'm going to say, suppose x is not 0. What do you think that means we're going to need to do when we're done here? Go back and say, well, what if x is 0, right? And if you forget to do that, then you're missing part of the problem, all right? I can only divide both sides of that by x if I assume x is not 0. Understand? Suppose x is not 0, then lambda's that. Then what? I can go to the second equation. I can go to the second equation, and I can replace my lambda with what? 2 over x. So I get from my second equation that 3 equals 2 over x times y. You with me? Solve this. What do you get here? How are you going to solve this? What are you going to do? I don't know what you're going to do. You could divide by 2, yeah?
Common denominator.
Okay. Why don't we, are you trying to get rid of this x over here? Like make it cleaner, like get rid of it? Or
I was thinking about moving the 3 to the other side and then getting 3x over x, putting it together as one fraction. Down in the bottom can't be 0. Solve the top for 0.
I see what you're saying. Get a yes, we can do a common denominator right now. Here's something I would suggest. I could clear this fraction out by multiplying both sides by x, right? Now the danger in that is that what if x was 0, right? X isn't 0. So I can clear fractions, multiply both sides by x right now, which is probably what I would do here. What I'm creating is a relationship between x and y. Why am I creating a relationship between x and y? What am I going to do with this relationship? If I know somehow x and y are related, like for example, I know that x is equal to 2/3 y, then what can I do from that? I can go to my third equation now. I can replace x with 2/3 y, and now I've got one equation that has just y's in it, don't I? So let me do that. The third equation now becomes what? This is x, right? So it becomes 2/3 y, that's x squared, plus y squared equals 13. Don't forget to square the fraction here. So this is 4/9, continuing here, 4/9 y squared plus y squared must equal 13. And then go ahead and continue on. How many ninths y squareds do we have now? 13/9. 13/9 y squared equals 13. What about multiplying both sides by the reciprocal? Get like y squared is 9, which means y is plus or minus 3. So as long as x is not 0, y is going to be plus or minus 3, as long as x is not 0. Right? What can we do once we know what y has to be? Come back and where is it? Where's x? Oh, this is x, right? X is 2/3 y. So once I know what y is, I'm going to come back and get x now. So that implies, I'm continuing all this. I'm just running out of room. That implies that x is equal to 2/3 times, I could say plus or minus 3. I hope that that makes sense to you. So plus or minus 2. Now we have to be kind of careful with this, all right? Because if y is positive, x is positive, right? If y is a positive number here, x is positive. If y is negative, x is negative. So the way I'm actually going to write this is as follows. Here's what I've got. I could have x be 2 and y would then be, what is it, 3? Or I could have -2 and -3. You follow? Where's my y? If y is positive 3, plug positive 3 in here, we get x is 2. If y is -3, plug it in here, we get x is -2. Yes? What I want you to be careful with is this. We are not saying this. This would not be okay, would it? That would not be okay. Because, look, if y is 3, is x -2? No. So just be careful with what we're saying when we're solving these. It's not just like, just because you see plus or minus doesn't mean every combination you could think of. They actually connect together sign-wise. All right, what am I still missing here that I haven't got? The lambdas, right? The lambdas. So let's see if we can get a lambda. Did we ever solve for a lambda? Oh, yeah, we did, right there. There it is. Okay, so if lambda is 2 over x, in this case, it would be 2 over 2, which means lambda is 1. And then same thing for this one, it would be -1, wouldn't it? Okay, we're done with that. That's what happens if x is not 0. What should we look at next? What if x is 0? We never looked at that, did we? Okay. So let me change this. Suppose x is 0. Now you can't solve for lambda, can you? If x is 0, what can you tell me? Y squared equals 13, right? But you've got another problem. Look at your first equation. If x is 0, what's your first equation say? Equation 1 says that 2 is equal to 0, right? And it's not. Which means x can't be 0, okay? But you had to think about it, because if you just, I heard someone say it, and that's okay. If x was 0, yes, it would imply that y is going to be, what, square root of 13 plus or minus? But see, x being 0 does not satisfy this equation. It has to be all three simultaneously. Okay. Anything else that we didn't look at? What about taking equation 2 and solving it for lambda, and then taking that and plugging it into this one? So what would I have to start my suppose off with? Suppose y does not equal 0. Right? If y does not equal 0, I can take my second equation and divide through by y. So that would get 3 over y equals lambda. And then I could plug into equation 1 with that. And my equation would be 2 equals 3 over yx. Starting to look a little familiar. This is what we did just a second ago. Clear the fractions. We get 2y equals 3x. And then I can solve this for x or y. I'm going to solve it for x. 2/3 y equals x. Isn't that the exact same thing we had earlier? Isn't this the same exact thing? So this is going to, from here on, it's going to be the same result. Right? Same result. We're going to have this right here. Because you're going to replace x squared with 2y, or 2/3 y. And then you're going to square it, and it's going to become 4/9 y squared, and you're going to move through the same thing, right? Okay. Is there anything else? You're going to have to do some jumping jacks or something. Yeah. Come on. Just go walk around or something. Is there anything else that I have not addressed or have not looked at? If y is 0. So yeah, what if y is 0? Suppose y is 0. Then what? Equation 2 says 3 is 0. That doesn't happen, so y can't be 0. If you do this, you can do that symbol right there. Just means contradiction. If y is 0, you get a contradiction. You're saying that 3 has to be 0, and that doesn't work. So these are two arrows hitting each other like that. Okay. See, this is the part that makes this difficult, is have we covered all the different possibilities? Yeah, I think so. Oh, you know what? Could we solve this for x and solve this for y? Could we? Okay, so suppose what? If I'm going to do that, then I need to suppose what? Suppose lambda is not 0. All right? Suppose lambda is not 0. What would equation 1 tell us? X is 2 over lambda? Yes? What would equation 2 tell us? Y is 3 over lambda. You with me? Got it? Keep going. What now? Plug them both into 3. So go into equation 3 now. What's x? 2 over lambda. Square it. What do you get? 4 over lambda squared. Plus, plug y into this. What do you get? 9 over lambda squared equals 13. All right. Put these together. You get 13 over lambda squared because they have the same denominator. And now just multiply both sides by lambda squared, which we can do because lambda is not 0. So you'll get lambda squared is 1, which means lambda is plus or minus 1. Have we done that? We actually did that already. Look at. See, you could almost look at this as in, look, those are all the, this is like, what if you had just started with this, said, hey, let's just assume lambda is not 0 and solve for x and y. You could have started the whole problem like this. And then you would have got lambdas plus or minus 1, and then you would have from that been able to come back and get what x and y were. So, I mean, there's just so many different ways. It's hard to finally get to a point where you're like, yes, I've checked everything. I've covered all the bases. Done this, all right? I'm just going to put done. We've checked that already. Anything else? Suppose lambda is 0. Contradiction, right? If lambda is 0, either 1 or 2 are going to be a contradiction. So lambda can't be 0. I'll put it down here. Suppose lambda is 0. Then this is the same thing, isn't it? Okay, that's it. It was a little more involved than the last problem, right? Yes?
Do you prefer solving it one way over the other?
No. My preference is that you cover everything you need to cover, and it doesn't matter which way you do it. I don't like grading these. It's very difficult to grade these. So I am looking for logical steps. You notice how I'm like bracketing out each of my, like suppose, bracketing it. The next problems are going to get even more challenging. And so what we're going to have is like within one suppose, we're going to have another like 2 supposes that break off to be like 2 more supposes. So we're going to have like these branches of ideas. And that's what I hope to see from you, is some sort of logical structure, not just random, algebraic crap all over the place. Because if you over here suppose y is not 0, and then over here you suppose y is 1, those things, am I supposed to guess, like, are they together, like y is not 0 and 1, or are you trying to let y be 1 and 0 at the same time? You have to get it all in order. If you try and do too much at one time, and you're not, I don't know how to explain this. If you get lost in the problem, you might potentially be trying to let a variable take on 2 different values at the same time, which would be a disaster. All right, so I just erased the important numbers. What were they? I need to check f of 2, 3, 2, negative 3. That's it, right? Or negative 2, negative 3. That's it. Check. Most likely, that's going to be your max and min right there. One of those is going to give you the max, one of them is going to give you the min. So 2 goes in, 26. The other one, negative 26. I think it's probably obvious that that's going to be your max and min right there. Questions? Here's the picture. Here's the plane. Here's the restriction. On the ground, there's the restriction. Can you all see it? Here's the points from the restriction plugged in. And you can see where it hits the surface, right? And we just found the 2 points here. One of them up here is 26 units high. The one down here, 26 units low. Yes? All right. Now we're getting into some nastiness. E to the xy is our function. Here are our constraint. Here's our constraint. X cubed plus y cubed equals 16. We should have Lagrange multipliers for sure, because this is an equation, right? Constraint equation. We're not given an unrestricted domain, right? We're not given a closed bounded set. This is just a curve, really, right, on the ground. So 3 equations. Partial f with respect to x equals lambda partial g with respect to x. Second equation. Partial f with respect to y equals lambda partial g with respect to y. Third equation, constraint, x cubed plus y cubed equals 16. Once I set up the equations, I get to go solve them. So what is the derivative of f with respect to x? Y e to the xy equals lambda times the partial of g with respect to x. 3x squared, but then times lambda, right? So how about I write 3 lambda x squared. See, if you mess the partials up, it's over, right? I mean, pretty much at that point, it's done. All right, the next equation is partial f with respect to y, which is x e to the xy. And then partial g with respect to y is very similar to what we just had, except 3 lambda y squared instead of x squared. And then our third equation is there. All right. Enjoy. What do you want to do? Find an x, y, and a lambda that make all 3 true at the same time. For those of you who've studied matrices and linear equations, systems of linear equations, we understand that there's a very systematic approach to solving systems of linear equations. It's called Gaussian elimination. Computers are really good at it because it's just do this, just operations, addition and multiplication, that's all it is. Systems of nonlinear equations, much more difficult to do. And you have to do them by hand and check a lot of different scenarios. So, all right, what do you want? You want to solve, I heard solve for what?
We could solve for x or y, because we know that e to the x and y cannot be 0.
Yeah, but that's not equal to 0.
But if we divide by e to the x to the y.
Okay, you want to divide both sides by e to the x
Yeah,
to the y.
that's what I'm saying.
Because you know that that will never be 0.
Right.
That's fair. We could do that. You want to divide both sides by that? Okay. I have no problem with that. Let's do it. So you want to divide. What's being suggested here, but hold on. Let me ask you before you put your pencil to paper on this. That's what I would get, right? But that's solved for y, but it's in terms of y still, right? Like to know what y is, you have to know what y is.
What about solving for e to the xy?
You could solve for e to the xy
On the equation.
on both of them. Or say again?
On both of them.
Solve both for e to the xy. I heard solve for lambda. They're both good. Do you understand the difficulty here? If you solve this for y, you haven't really solved it for y. Because you still need to know what y is to know what y is. Right? Like if I have like x equals 4 plus 1 over x. Have you solved for x? In order to know what x is, you have to know what x is, right? So, all right, so let's take a vote. Are we going to solve for e to the xy on both? Or do you want to solve for lambda on both? E to the xy? Lambda? Okay, let's show hands because I can't tell by how many. Okay, how many of you want to solve for lambda? Okay, e to the x, y. Wow, that's close. That's close. Okay, we'll go to the coin flip. So, no distinguishing marks. That's heads. Heads is lambda. Sorry. Heads was lambda. I should have called that. It's like the Super Bowl flip. Okay. It's going to be lambda. We're going to go for lambda. All right. Yeah, it didn't flip. All right. So if I'm going to take equation 1 and solve for lambda, then what do I need to say? Suppose x isn't 0. Suppose x is not 0, right? Equation 1 becomes that, right? Now, what would you like me to do with that? You plug it into 2? Or we could solve the other one for lambda also and set them equal to each other. I'm just going to go right to 2 in this one. Although setting them equal would be the same. But I will say this. If you solve the second one for lambda, you're going to also have to tell me what? Suppose y is not 0. So you're fixing them both then. I'm going to stick with just, right now, the only condition I have is that x can't be 0. That's the only thing I'm saying. All right, so let me rewrite this now. I might, at the end of the day, have to say that y can't be 0 either. But 3, here's lambda. Lambda is y. E to the xy over 3. Oh, I like that. It's going to cancel. And then y squared. Did y'all see that Diaz fight? That Conor McGregor-Diaz fight? All right, there we go. That I can do, right? Cancel those. What else could I do to make this a little bit nicer? Can I clear the fraction? Can I multiply both sides by x squared? Yes, because I'm saying x can't be 0, so that's a legal move. Right? If x is 0, then I could potentially multiply both sides by 0, and that's, you never want to multiply an equation by 0 on both sides. But x isn't 0, so this becomes x cubed e to the xy equals, what's over here? Y cubed e to the xy. Now what? You can divide out e to the xy now. I just told you, don't ever do that with a variable, but we all know that e to any power can never be 0, right? So I can divide this out safely without any concerns.
You see that I was seeing this.
Yes. Which means x cubed equals y cubed. X cubed must equal y cubed. So far, that's what I've got. If x is not 0, then to satisfy things, x cubed has to be y cubed. Now, where can I go from here? The third equation. In the third equation, that would imply that, which one do you want to replace? You want to replace that with y cubed or this with x cubed? Doesn't matter, right? So I'll replace x cubed with y cubed. Oh, look how nice this is going to be. 2y cubed equals 16, which means y cubed is 8, which means y is 2, not plus or minus, right? Just 2? All right. Now what?
Is it going to be plus or minus or just not?
Just plus because it's a cube, not a square. That means x is 2 because of this equation, right? Which implies that x is 2. Hey, this is promising. I've got 2, 2 so far, right? Can you give me what lambda would be in this case? Do we have an equation with lambda in it? Right here. Replace your y with 2. It would be, I'm telling you how I'm getting lambda here. 2e to the 4 over 3 times 2 squared, which is e to the 4 over 6. Whatever that is, who cares what it is. But there is a lambda, e to the 4 over 6. Everyone understand? All right. I'm only putting my marker away because it's starting to die a little bit. Am I done? What else do I need to look at?
That was just not understanding.
That was just saying that x wasn't 0. That's what happens, right? That's because y'all wanted to, well, no, the ruler wanted us to go and solve for lambda. So maybe we should check before we forget that, what happens if x is 0? What if x is 0? Are we going to run into any problems if x is 0? What's the problem we run into? Where? What equation? The first equation? If x is 0, the first equation would become y times e to the 0 because of this, right? Equals the right side, which is 0. Which, if you divide both sides by e to the 0, which is 1, or just turn that into a 1, this means y is 0. I don't see a contradiction yet. So that's OK? So if x is 0, y is 0. But the third equation is going to fall apart. Look at the third equation. In the third equation, what do you get? 0 cubed plus 0 cubed equals 16. Not happening. Got it? So that's not going to be the case. So I can't let x be 0. If x is 0, I'm never going to satisfy the last equation. With me? Because in order to satisfy the first equation, I have to let y be 0 also. So letting x be 0 forces y to be 0, and as soon as that's done, the third one's never true. What else do we need to look at here? What is that? Y, what? Oh, suppose y is 0 or not 0? OK, suppose y is not 0. I'll do it back up here. Suppose y is not 0. What are you going to go for lambda in the second one? Is that what you're going for? No? Is that what? Didn't we solve for lambda in the first one?
Yeah.
Plugged it in here and then got all our stuff? What if we try and solve for lambda in that one? We're probably going to get the same thing. Suppose y is not equal to 0. Equation 2 becomes x e to the xy equals over 3y squared equals lambda. You following? Same sort of logic as before. Okay, then number 1, from number 1 I can replace it's y e to the xy equals 3 times lambda, which is x e to the xy over 3y squared times x squared. Do y'all see this is exactly the same thing's going to happen? Our 3's are going to cancel. The e to the xy's are going to cancel. I bring my y squared over x cubed. So I'm going to have y cubed equals x cubed again. Check. We've done that already, haven't we?
Do you want to show this separately? If we can see that the same thing is going to happen for when we're doing x can be 0, can we just write down that the same happens?
Yeah, you can. You could just make sure you say, suppose y is not 0, and we're going to get the same result. Just make sure you state it, because I just don't want you to forget to check things, that's all. All right, what if y is 0? Suppose y is 0. Contradiction, right? We're going to not be able to get this one to be true. So that means we only have 1 point, right? What's going on then?
It's like another side.
Let's take a look at it. Something's going on here. First of all, this is, oh, well, I should erase some of that stuff, huh? I have the domain graphed separately here. That's your constraint equation. That's x cubed plus y cubed equals 16. Right there. That's what it looks like. If I plug just those points in to this, make one of these smaller. First of all, let's look at the domain on the ground. See the domain on the ground? If I plug just those points in, it's where this green thing intersects